Hess's law. It states that if a target chemical equation, let's use this example down here, okay, so this here is our target equation, okay, it's equal to equation 1, 2, and 3. In this case, we only have 2 equations, so that's fine. And then we're just going to get the heat of the reaction, so this is the enthalpy change, right? So this one over here, part of this thermochemical equation, is going to be added with the heat of the reaction of equation 2, so the sum of these together, the sum of the enthalpy of all the other reactions, so these 2 reactions here, has to equal the target chemical equation, okay? So the target chemical equation also has a enthalpy, so it's going to be a total sum of these other heat of the reactions added up. Let's have a look at an example here. So we have our target equation. We need to make 2NO2 on our reactant side. The problem is it's a product right now, so what we're going to do is get rid of this and turn it into the other side. So now this negative 66.4, sorry, this positive becomes a negative 66.4, so that we have a reactant, our 2NO2. So we're just going to get our 2NO2, put it on the reactant side. This is still the reactant side, so we're going to add that, and this is also a reactant. So we're just going to put all these reactants together, and then it's going to create a product. So this is now our product, so we've added that here. This is still our product, so we're going to add that there. You're just going to now sum up the enthalpies. So you just get negative 66.4 and 11.1, you get negative 55.3, and then of course, if these are the same, on those different sides, you just cancel them out. Same thing here. Okay, so you're just left with this. Let's have an example here. All right, we have a target equation here. We obviously want CO. We want 1 CO. The problem is we have 2 sets of COs. We have 1 mole here and then 2 moles here. Well, if we put these on the opposite side, so this and this on the opposite side, so as you can see here, what I've just did, I flipped it. So then this becomes a negative, and then this one stays as a positive. So 2 minus 1 will give you our 1 CO. So that's what we're going to be doing. If we flip this, that means this also has to change into a positive 283. Now we're just going to be putting all the reactants together. So this one and this one and this one are all on the reactant side, and then this one here, and this one here are all on the product side. Now you just line up our enthalpy. So you got 283 here, you get negative 247 here, and negative 241.8 over here. You just add them all up, you get negative 205.9, and of course the ones that are the same, you just cancel them out. So this cancels out, this cancels out, then this one, there's only 1 left, this one cancels out, and this one cancels out, and this one cancels out. So you're just left with this, our 3H2, our CO stays over here, and then of course our CH4 is still there, and then H2O is also still there on the product side. Please give this one a try on your own. I'll be giving you the answer. This is the answer.